Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem that is the maximum score from performing multiplication operation. This is a middle level question and we'll see what this question is asking us to do and how we can solve a question like this. Okay, so before moving on, if you haven't subscribed to Learn Overflow, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. Let's understand the question. The question says you are given two integer array, nums and multipliers. So that's the num and multipliers being given to us. Fine. Further, this is the nums of size n. Okay, nums is of size n, and our multipliers is of size m. Fine. Respectively, where n greater than equal to m. So n can be greater than equal to m. So also it mentions the array is one index. So what's the point it makes when it says one index or zero index? When it says one index, then everything they are saying is like considering that it starts from index one and goes till index n. But in reality, our array starts from index zero and goes till index n minus one. Fine. So we just need to do a minus one for every case. Based on what they are saying, we just need to do a minus one. That's what they are mentioning over here. So the array is one index. Further, you begin with the score of zero. So initially it has a score of equals to zero. Fine. Uh, that's a score we have initially. Fine. And then we want to perform exactly aim operations. So exactly aim operations need to be performed on the ith operation, that is I index. Now, what are the aim operations? Aim operations is we choose one integer x from either end of the num. So nums is an array. Fine. From either end of x, either you choose this one or you choose this one. One integer will choose, and then with that integer we'll multiply with ith of our multiplier. This ith of this multiplier I into x. Okay, so we'll choose one integer from left or right, and then from either of the multiplier we'll choose that, and then we will remove that x from the num. So whichever element we choose from our nums element, we'll remove that. So in practical situation, removing an element from an array is not possible. So what we'll do, we'll just make two pointers pointing at left and right, and whoever is used, we'll just move our pointer to the next element, considering that the previous element doesn't exist anymore. Okay, so that will be the idea we can will achieve that. So we'll remove x from nums. Fine. After that, it says return the maximum score performing aim operation. After performing aim operation, you should return the maximum score. So if the example that they gave is like 1, 2, and then 3, fine. So in that example, we find that there's another multiplier array that is 3, 2, and 1. So it just took 3 and 3, as it says 3 and 3 and took 9. Then like first it got a number 3, and then with that number I just look for the maximum of 1 or 3, the both side maximum, and just took out the maximum number and then multiplied it with 3. Fine. Then it got 2 and took out the maximum from the both ends. It got 2, right? And then from 1, only 1 was left, so it just got 1. So that can be a thought process we are finding it, but this is not the correct way of thinking, because the next few examples will just blow your mind when you just try to think of this way. So what's our next example is saying? Our next example clearly says, see, in our next example, that is example 2, we were given, wait. So in the example 2, we were given nums array is -5, -3, -3, -2, 7, 1. Okay, so that's the nums array being given to us. Now, in this case, we have a multipliers 10, -5, 3, 4, 6, right? Now, in this case, look, if we just go ahead and first thing we got -10. So if -10, if we just go ahead with 1, okay, that's the max of left and right. If we go ahead with 1, we got like 10. But if we have went ahead with -5, we got 50, right? -10 into -5 got 50. So you might think, okay, so we need to find a max of either a multiplication of left hand number and multiplication of the right of the number. So if you're thinking on this side, you are somewhat correct, but not the exact thing, because again there will be something that's hidden within it. Okay. Now, so simply you just multiply these two values and try to gain your number. Like -5 into 10 is 50. Then -3 into -5 is 50. Then from the left, the two numbers are gone, and these two numbers are gone from here. Fine. So these are gone. Next thing we got another -3 or 1. So next we got 3. So in this case, what we will do? If you get 3 and -3, our multiplication result is in -9. But if you get 3 and 1, our multiplication results in 3. So what is the maximum value can we get? We can get a maximum value of 3, right? But that's not the way we should go ahead with. We should go ahead with -9. Okay. Why and how I'll discuss. Next thing they say we got 2 -2 7 or 1 only left over here, and that's 4 6. So for 4 we went ahead with 1, that's the maximum, and then 6 we went ahead with 7, that's the maximum we got over here. Fine. So this is the way we found out that this is a 102. But if anyway if we have chosen here -3 into 1, okay, by any chance if you have chosen in this step, okay, -3 into 1, then we have got -3 over here. So you might think that is saving our value, but in the other case we got a array of -3 -2 7. Fine. Now what we'll do, we got 4. So 4 we can select -3 or 7. So if we have selected like -3, 4 into 7, so that will result as further. If we just went ahead with something like for like 4 into 7, like 4 into -3, that will result in -2. So it can either result 28 or minus 12. Fine. Then we got 6. We got 6, and this for 6, we see if we wait on the maximum value, we are left with -3 and -2. So 6 into -2, like that will be the minimum. Obviously, 6 into say -2, so that will result in -12. Now see what is the total subtraction is going on, -3 and -12. That is -15. So in the other case, we got only a -9 additional subtraction, right? But here we are doing a subtraction of -15. So this is not the way. So in that case, that's why we took -9. I'll give you another example. This will be much helpful for you. So what if our nums array is something like this: -10, 1, 1000, 1, 100. So and the multiplier string 1, 1, 1. Okay, so 1, 1, 1, take just multiply and you'll see the results. Now, for the first one, okay, what we are supposed to take, -10 or 100. So okay, so if we have taken 100 -10 for the like if you have taken 100 for the first one, so that becomes 100 plus anyways the maximum value should be like 100 plus 1 and 1. You can go this way, right? If you have chosen like -10 in the next step, still you can reach this one. Okay, so it can be 100 plus 1 plus 1. That's the case. Like I'm choosing like if all three are chosen from the right side, right? The next is can be if you have chosen 100 first, then 100 plus you say in the second case you thought like okay, let's not go with 1, let's go with -10. So that's like -10 you got over here, okay, and then you got 1. So that's the one. Like one from either side, or you choose this one or this one. It doesn't matter. You just got one, okay. And that's the three cases if you start from 100. But what if we have started from -10 in the beginning? So if we have started from -10 in the beginning, so we can reach, say -10 we got. Next we are supposed to take 1 or 100, fine. If we take, if we have taken 100 as a greed, so like out of greed, if we have taken 100 and then we will reach to 1, fine. But in the other case, what can be there? What can the maximum values like -10 you got? Then you got a 1, 1 I mean going all from the left. And then you got 1000. So when you get this 1000, you only need to take -10, 1 and 1000 to just reach to be a value of 1000. If by any chance if you take 100 in the first instance, you cannot reach a value like this, right? You cannot reach a value near about this. So once we are seeing this kind of question, that this being greedy with our choosing of the nums is not the solution we're looking for, right? Being greedy is not giving us the proper solution. So we now know that we need to keep a track of this, like to keep a track of what we should be finding out, right? And that we should like it's more like a tree. Okay, let's think of a tree. We have two decisions: either take a left or take the right, and then ultimately figure out which one is like breaking it down to all the cases and ultimately figuring out which one giving us the maximum value at the end. Fine. So this is the case we got. like first we got a choice of -10 or we got a choice of 100, fine. Then from -10 we got a choice of choosing 1, or we got a choice of choosing 100. So that's the cases. Then from 1 we got a choice of choosing 1000, okay, or we got a choice of choosing from 1, or we got a choice of choosing 100, fine. In the other cases, if we got if we got choose 100 in the initially, then we got also two case. So the maximum we need to find on which way we actually come up with the maximum value. So that's what we need to look for. So if we take an example, something like this, like 2, 100, -1, and 2, in that case, see, we got an equal example. So greedy is not a case with us, okay? Being greedy, we cannot find which one to take. But if by chance we took a path like this, we cannot reach a maximum value. We need to take a path like this, okay? So what the initial thought that being greedy will choose the maximum from here or maximum from here is not a way we are looking for, right? So that should be clear till now, okay? That should be clear for you that if we are trying to be greedy and try to reach a solution, so in that cannot be a solution we are looking for, fine. So as I say, the solution will be something like it's just like it has the first case, it has got two options to select two, that's the left two, and to select the right two, fine. And further, after it selected the left two, so it got two options further, either select 1000, fine, and or select right two because that is not selected, fine. So after 1000 selection, we are done with our multiplier select. But if I select right two initially, then it got two options, either select left two or select -1. That's the two options we got. So that's the way the flow diagram is going on. Okay, so that's the way it's moving on. Now, if we are now, how will you solve this? Okay, you can solve this directly like in this format. Like you got a left pointer, you got a right pointer, and you got a multipliers counter, like the or operations, like how many multipliers have been done. Okay, so just pointer to that. Okay, so if we just keep that check, okay, then you will find out like keep on calling multiply like left plus one. Either if you're going with the left, then go for left plus one, right, and operations plus one. Or if you're going with the right hand, then you go for left, right -1, and operations plus one. Okay, simple two values. Like if you're going with the left, okay, then we'll go for left. Like the next values we'll look for left plus one. Now once we took the left, then we see left plus one, and then right, fine. So those are two values I do, and we do operations plus one. Okay, then like our operation plus one is just the counter of this multiplier. So initially operation is 0, so it just got over here, and then plus one is will got over here, fine. If you are going for the right, okay, our right will be like we'll take a continuous like left, right -1. Like from the right, we are subtracting right -1, and then we'll again do operations plus one. Fine. So those are the these are the idea. Now, ultimately, we'll find the max of left and right, the who is giving a max of that in each stage, and we'll return. We'll keep returning the max. So that's the point over here, right? But let's understand something. If we try to do this, this may not be the optimal solution. Like we got a solution, right? We got a kind of solution, but this may not be the optimal solution. Why is it so? Why I'm saying, see, if we got a value something like this, okay? If you got a value something like say A, B, C, D, E, right? And along with A, B, C, D, we got our multipliers as X, Y, Z. I mean V, W, X, Y, right? So these are the 5 multipliers we got. Now, for this particular case, what is the situation we have in hand, right? So if we got like something like this, now first we got V. For V, say for V, we got two cases, right? For V, we got two cases. Like I'm just taking over here, right? For V, we got particularly two cases. One is if we can take with A or we can take with E. Fine, that's the V. Now next step we got what? We got W. If we got W in our next step, like say we got W in our next step. For W, we got two cases. If you have taken A initially, then we got B and E. So for W, we got B and we got E, right? And for W, if you have taken E initially for V, then we got again two cases. That is the A and D, right? That's the two cases we got. And now for next is like X. Okay, so next is we got X, fine. For X, we are getting again two cases. If I have taken B initially, then we got C and we got E, fine. X with E and also like X in all the cases, fine. So X in all the cases will be there. So in the other case, if we take X from A, fine, and like from this path and we stick with C, if we break over here, then we got what? We got B on its left, okay, and we got E on its right. Exactly. So we got B on its left and E on its right. That can be two ways possible. Like the thing is like no, not E on its right. E is already used, so D on its right. Fine. So there's a two paths we can actually take. Okay. So this two can be the first. Now see the problem comes over here. If we take X with like X with E, then what the situation comes up. If we take X with E, then we got our next value, that is a Y. Fine. Y got two values. Now Y, if we are done with A, B in the left and E in the right. So Y got C on its left and D on its right, right? Because E is done, so D on its right, and AB is done, so C on its left. Now, in the similar way, if we take B on this X path, then we got an Y over here, and for B, after that, we find that Y will have C on its left or D on its right, because in the same path, E is done, AB is done, right? And in a similar way, in the other part, AB is done and E is done. So Y got two options, C and D. Now see, this is a repetition that is occurring over here. Fine, this is a repetition that we can see over here, because Y got two options, C and D, and that's the last option. A bit like whatever Y will choose, Z will follow the other one, right? That we don't have other options. And similarly, that's the kind of the input, right? So we find a situation, we are falling in a situation where you see the paths are getting repeated, or the sub problems we are coming across is like repeated again and again, right? So whenever we find repetition of our sub problems being done, then our approach should be a dynamic programming. Yes. So this is a solution, and you can see this is a 30 millisecond solution. Like it is pretty much faster. Okay. So let's understand what exactly we did in our solution. So first thing, as I said, we took a DP array of length m, because that's the number of operations we need to do. Now we started for m minus one. Okay. So let's create an array, DP array, based on that. Fine. So let's take the smallest example we got, and the smallest example we have is this one. Okay, so 1 2 3 and this 3 2 1. Right. Then let's create a DP array based on this. So we got three elements, right? We got three elements for us, and then in the three elements we like this, right? So initially we our three elements were like 3 2 1, that's given to us, and we created a of length being m, okay, of length being m. So we create a new array of length being m plus 1, that is 0 to m. So 0 1 2 and then 3, that would be something more, something like this. Fine, that's the DP array we created, and now we started with I equal to m minus 1 till 0. So first thing is I was m minus 1, right? This is our DP array, right? So that should be clear. So first thing is I is m minus 1. When I is m minus 1, so if we just look in this array, it's like 0, 1, 2, 3. 3 was the length of the multiplier, so m minus 1 is something like this. If I point I in I, DP of I will be something like this. But we will not go with DP of I, right? We'll go with something else. Let's see. So next thing is what I did is like multipliers of I. That's a value. So if I just took it in a variable. You may not take it in a variable, simply do with multipliers of I in our multiplication. No problem will be there. So if I take multipliers, like I'm taking multipliers as this array. So this array is what we have currently. We have 3 2 1. Fine. 3, 2, and 1. This is the array we got. Fine. Next, we got multipliers of I, and then we got our nums. If we just say nums, so what's our nums? Nums is 1, 2, and 3, right? So this is the nums we have. Now let's dry run this and try to understand. So first thing, 3 multipliers of I. So multipliers of I is this one value. Now we took that in our as a variable called month. Okay, so that's a variable. Now from left, from int I equal to 0 till like L equal to 0 till I. So what's the value of I right now? Right now is m minus 1. Okay, that is currently at pointing at 0. So sorry, pointing at 2. If I just say I is initially 2, m minus 1, m being 3, I being got 2. Okay. Now our L, so our equality of L becomes something like 0 initially, right? So first the R becomes over here. You see, what's our R is becoming? If our L is there, R is becoming something like n minus 1, n being 3, the length of the nums, n minus 1, there is 2, minus I minus L. What is I? 2, minus L is 0, I minus L is 2. So n minus 1 is also 2. So n minus 1 minus 2. So that is R is initially 0. Fine. Now let's go further. What I'm trying to do, I'm taking two variables left. Okay, I'm taking two variables left, and then other variables is right. Fine. So we just got sorry. Fine, just consider this is the right. Okay, this is two variables we got. So what we'll do with that, we'll simply we're doing nums of L. What is nums of L? Nums of L is something like, what is the L? L is 0. So nums of L is 1. So 1. And similarly, in the right, we're taking nums of right. Nums of right is also 0. So nums of right is 3. Okay. So we just see, we're just taking two values over. So we're just multiplying it with it. And then we got a multiplication being pointing at this one. So anyways, both are pointing in what, right? And then with that adding dp of L plus 1. What is L? L is 0. So dp of L plus 1 is something like, if L is 0, then L plus 1 like by default is also 0. Fine. So we are just adding 0 with it. So like if you remember, like yesterday's video also I say, like for an array is being initialized, initially the all the values are 0 in Java. So and with that, and also on the right, what we're doing, we're simply doing dp of L. By default it's 0. So that's we got left and right. So what's the max of left and right? So dp of L is max of left and right. What's the max of left and right? 1 into 1 plus 0 or 3 into 1 plus 0. We got 3 into 1 plus 0, that is 3. So dp of left, this L value is something is directly we got as 3. Fine. That's what we got our value initially. Next we'll move to the next. What will increase? Our L will increase. Fine. We got an increment in our L. So an increment in our L, our this left and right value will change, and our this L and R value will change. I is 2 for this particular loop also. Even mul value is also standing at 1. Okay. So let's quickly see this. So we got our L value increase. So L value becomes 1 in this case. Fine. Now we'll again need to calculate the right. Right being n minus 1. N minus 1 is 2, and then I minus L. I minus L is there's 2 minus 1 is like 1. So then n minus 1 is 2 minus 1, that is 1. So right value becomes 1. Okay. So that is n minus 1 is 2 minus that's 2 minus 1, right? 2 minus of 2 minus 1. So that's 1. Okay, so 2 minus 1 is 1. That's how it reached out in our case. So that's the R being calculated. Then again, we are finding a left and right. So nums of left, what is the nums of left? Nums of 1. So nums 0, 1, that is 2. Fine. What is the nums of right? Nums of right is 0, 1, that is 2 again. And we are multiplying this with our mul. So what is the mul? Mul is 1. Fine. That's the variable we got. And then we got dp of I plus 1. dp of I plus 1, dp of L plus 1. dp of L is something like setting a 1. So dp of L plus 1 is what? dp of L plus 1 is 0. So plus 0. And dp of L is also setting a 1. So at current position also there's no value. So we got 0. Okay, for next value on us, we will get a value. So what is the maximum? So 2 into 1 plus 0, 2 into 1 plus 0. So that's 2. So that's how that's the how we are moving forward. Okay. So in the first run, we'll get a value fixed for this position. Okay. From next run onwards, we'll just try to fix our value. Okay. And ultimately, for the dp0 will be our final answer. Fine. So it's like top down kind of approach. You're breaking into it and then moving back. Fine. If we just move ahead further, then we'll see that our L value will get increased, right? Our L value will get increased quickly, and then similarly our right value will be changed as well. So what our L value will be? L value will be something like 2. Okay, that's the only value we have, and L value we got 2. And then Moving further, we will get r being n minus 1, that is 2, minus 2 minus 2, that is 0. So r we got 2 as well, fine, in this case. And then what's the further? Left is 0. Sorry, nums of left is 3, fine. Nums of left is 3 and nums of right is 3 as well. Okay, so we got nums of left, nums of right multiplied by our mul value, that is the 1 we got only. And then what is that? dp of I plus 1 is 0 and dp of I is 0. There is L and L plus 1. So 2 and 2 plus 1, 3. So this two the values that we're going and we got 0. What's the max value we got? Max value we got 3. Okay. And then what's the I value? I value is 2 and L is already become 2, right? So we'll not go further. We'll change our I value. So I value here changes to 1, right? So now in this case, all our I value will change. So I value will actually change to our 1. Now, what exactly will happen to the I? This reduced to 1 and the left will be 0 initially, fine. And then we'll say right will be n minus 1. N is fixed 3, 3 minus 1 is 2. So 2 minus I minus L. So I minus L is 1. So 2 minus 1 is 1, right? Right is standing at 1, fine. Now see what will happen. It will simply go ahead with we'll talk about the left and right. Left and right will be num into num of left L. So num of 0 is 1 and num of right, that will be r is pointing at 1. So that's 2, fine. So and we'll multiply it with what's the I value? I value is changed, right? I is pointing at this position 2. So we'll multiply this with 2. Fine. What we are getting over here and plus dp of L being 0. So dp of L plus 1, 0 plus 1 is 1. So plus or 2 over here and this will be plus our dp of L, that is 3. So 2 into 1, 2 plus 2, 4 or 2 to the 4 plus 3, 7. So what's the max value? So dp of L being 0, what's the max value? We got 7. So change this to 7, right? We got a incremented value 7. Now, similarly, we'll again move ahead with our steps like we'll increment left being incremented to something further, like one. Okay, so that's the only one operation will be there. See, only one operation will be there. Left incremented to 1, and then once left is incremented to 1, we will calculate our right as well. So what is the right? Right is something like n minus 1, that is 2 minus 1 minus 1. So 2 minus 1 minus 1 is 2 itself, fine. So that's what right is coming up with. So if you just look carefully, this left and right are actually pointing up like a place of memory or a length of memory we are pointing. Okay, so we got left and right, and then let's check our values in the sense nums of length, nums of L being 1, so nums of 1 being 2, fine, and nums of right being 2, that's 3, fine. So right is 3. So if we just multiply this with our 2, okay, multiply with our 2, we got, and then what we need to add? dp of L plus 1. L is 1, so 1 plus 1 is 3. So that's how we add to it. And what we're supposed to add here? dp of L is 2. So 2 to the 4 plus 3, 7, or 3 to the 6 plus 2, 8. Okay, so dp of L will be 8. We are changing it. And then see, can L increase further? L is already equal sign. No, L cannot increase further. So we will not go to this, change this 3 further. Okay. So what we'll do, we'll simply go ahead with change our I, change our L, change our R. Now, what is our I will change to? I will change to the next lower value. That is, we started from 2, we gone to 1, and now we'll go to 0, right? So that's what our I will become a 0. So here I become 0, fine. What is the L? L becomes 0 till I. So L initially one case possible, that's 0. And for right, we got what is your R? So n minus 1, that is 2, minus 1 minus 1, like 0 minus 0, so 2, that's 2. R got 2, fine. Now, similarly, nums of length, nums of left is nums of 0, that is 1, and nums of right, that is 3. We got 3, fine. And see, like if you just look carefully, so I is 0, so we are pointing at this position, and in this position, see, we got two values, nums of I and nums of 3, right? Two values to multiply to, right? So that's what we are getting. So this is the exact beauty of this code, like how we are going ahead. So we are going in the reverse order, so you might not be able to get the essence, but when you are at the beginning, Now you can see that we got two values to select for. So 1 into what? Minus this 3 over here. Fine, minus 3 over here. And then we'll to our left we'll add dp of l plus 1. L is 0. So 0 plus 1 is 8. And over here we'll add dp of l. dp of l is 7. Fine. So that's what we got. And then so 1 into 3, that's 1 into 3 or 3 into 3 we got. Okay, and then we added our l plus 1 to our left, that is the 8, and we added our l being over here, and with what's the value we got? 8 into 3, 9, 10, 11, and we got 7 into 3 is a 9. Okay, this is a 9 plus 7 is something like if we go for 3 is a 9 plus our 7, then it's like 9 plus 7, that's something resulting in 16, I guess, if I'm not doing a calculation mistake. Then that's the case. So then 8 into 3 into like 1 is 3, so 9, 10, 11. Fine. So it's resulting in 16. So I think so the max value comes out to 16, but I think there's some kind of calculation mistake I did in between. So it will result in something like 14. Fine. So that's what it results. If you just run this code, you'll find that's what it results into. Right. So that's what it is. It results in. So we can actually break this code, like we did the whole thing on our own. So we can actually break this code to just find out, like give some comment lines in between, and we can find out all the values we're trying to break the breaking of the sentence. So this is the way it works. So I think a small calculation mistake happened, so that's why it resulted in 16 for me, but it actually results in 40. So this is the way it actually works for us. Okay, that's the, as I said, that's the beauty. When you look for the first number from us, you will see that both the numbers are taking place. So that's how it's working, and we get our like pretty fast solution. That's the 30 ms, and you can see it's faster than 98% of the solutions. Okay, so that's more or less about this idea, guys. If you have any doubts on it, make sure to comment them down. I'll be happy to help you out again in the comments as well. Also, subscribe to this channel and make sure to like the video and share it with your friends who are doing today's LeetCode problem. So that's about this video, guys. Thank you all. Thank you for watching this video. Hope to see you soon in my next video as well. Thank you.